Okay, so this is part 2 of our discussion under chapter 1, functions. So video we discussed about the definition of the function, the dominant range of the function, the different classifications and the notations, and we also show uh, you we also discuss the graphs of those functions. So in this video, we will be discussing the final half of chapter 1, and it's about we will evaluate a function. We will compose and combine functions, and also we will discuss some special types of functions for the last part. So first, evaluation of a function. So how do we evaluate a function? So how do we evaluate a function? So let's take an example for you to understand the principle behind this one. Evaluation sample. So let's take an example if f of x is equal to, let's just make it simple, 2x plus 3. Now I want to determine the following. A, what is f of 2? B, what is f of negative 3? C, what is f of A? D, what is f of x plus 2? Letter E, what is f of x? 2x minus 8. So let's solve this. So remember, f of x is equal to 2x plus 3. So solution for the letter E, for what is f of 2? So to evaluate a function, this is the technique. You take the original function. So this is f of x equals to x plus 3. You change the value here inside the bracket. If you want to solve for f of 2, then all the x at the right side of the equation should be changed to 2. So in this example, so f of 2 now will be equal to 2 times x, but instead of x, we substitute the value of 2. That's evaluation. We substitute the value of 2, so we just change that 1 to 2. So instead of x, then plus 3. So f of 2 now will be 4. 2 times 2, 4 plus 3, or it's the 7. So that's f of 2. For letter B, f of negative 3, it's the same, still the same. You change all x with, instead of 2 now, we change it to negative 3. So 2 times negative 3 plus 3. So f of negative 3 now will be 2 times negative 3, which is negative 6. So this is negative 6 plus 3. Negative 6 plus 3 is negative 3. Then for letter C, we just change the x with the letter A. So it's direct substitution. So f of A is just equal to 2 times A plus 3. So that's f of A. For letter D, f of x plus 2. So again, we change the x. So 2 times this one, 2 times x here, but instead of x, we change it with whatever inside the quantity, and that is x plus 2. So this will be x plus 2. Then we continue, plus 3. Simplify further, so this will be 2x plus 4. 2 times 2, 4 plus 3. So therefore, f of x plus 2 will be equal to 2x plus 4 plus plus 3 plus 7. So f of x plus 2 is 2x plus 7. And the last part, the last letter E, f of 2x minus 8. So this will be, again, substitute 2 times 2x minus 8 plus 3. Then distribute 2 times 2x. Then 2 times negative 8 is negative 16 plus 3. Negative 16 plus 3 is negative 13. So f of x, 2x minus 8 is equal to 4x minus 13. So this is how we evaluate a function. So we just need some algebra skills to simplify them and to solve them. So if you know algebra, then it's easy for you to evaluate any type of functions. Later on, you can solve more complicated functions. You can evaluate them. So let's take another example, a much harder example. Let's level up example. If f of x is equal to 2x cubed plus 7x squared minus 2x plus 3, determine f of x plus 2. So we just need to determine f of x plus 2. So solution. So f of x plus 2 now, again, we change all x with the new value x plus 2. So this will be x plus 2 cubed plus 7 instead of x squared. This is x plus 2 squared minus 2 times x, but it's x plus 2, so 2 times x plus 2. X plus 2, then plus 3. X plus 2. Then that's evaluation. We already evaluated the function, but we still need them to be simplified. So how do we simplify them? Here, x plus 2 cubed. So we need to take the cube of a binomial. So this is quite tedious. So 2 times, take the first term, you cube the first term. Then, because it's plus, so it's also plus 3. Why 3? Because it's cube. 3, then copy, take the first term again, then you square it, then copy the second term, multiply it with the second term. Then it's still plus because the sign is plus 3 again. Then now, the square will be at the other side, so this will be 2 squared. Then plus 2 cubed. So if you remember here, I just take a note, algebra, x plus y cubed, this is equal to x cubed plus 3x squared y plus 3x y squared plus y cubed. So that's the basic algebra. Then continue, this will be equal plus this, the second term, this is 7 times x plus 2 squared. So how do we do square of a binomial? So x plus y squared, this is x squared plus 2xy plus y squared. So here, this will be x squared plus 2 times 2, 4 times x plus 2 squared, 4. Then that's it. Then minus 2x, then minus 2 times 2, 4, then plus 3. Then if we simplify this one, so we will have 2 times x cubed. 3 times 2 is 6 x squared plus 3 times 2 squared. That's 12x. Then plus 2 times 2, 4 times 2, 8. Then 7, we distribute 7, so 7x squared plus what? 7 times 4, it's 28x plus 7 times 4, it's 28 minus 2x, negative 4 plus 3 is minus 1. Then we continue. F of x plus 2 now will be equal to, so I'll just put the answer here, 2, so we have only one x cubed term, so 2 times x cubed, so this is 2x cubed. Then for x squared, we have two terms. For x squared, we have 2 times 6, so that's 12 plus 7 here, 7x squared, so plus 19x squared. Then for x, we have 3 terms for x, so 2 times 12, that's 24. Then you add it with 28, 24 here, plus 28, this is 52. Then we subtract 2, so that will be 52 minus 2, so plus 50x. Then the last part, 2 times 8 is 16. Then 16 plus 28 will be 44. Then we subtract it with 1, so 44 minus 1 is plus 43. So this will be our f of x plus 2. So you can evaluate anything you want as long as you know how to do some algebraic manipulation and operations. So that's how we evaluate our functions. So now, the next topic will be, now that you know how to evaluate, we can now combine functions. So this will be the next topic, combinations of functions. We will be discussing two types of combination. We only discuss two types. The first one is the arithmetic combination. Arithmetic combinations of functions. So how do we operate functions? How do we combine them arithmetically? So these are some properties. So letter A, if we have f plus, so before we do that, let me first define. So let f of x and g's of x functions, to be functions, to be our functions. So if f of x and g's of x are functions, then these are some properties of arithmetic combination. If we want f plus g of x, this is some notations. This means this is equal to f of x plus g's of x. But take note, remember, this one is not a multiplication. F plus g times x, it's not a multiplication, it's f plus g of x. This is a function, a combination of functions arithmetically. So it's just like we distribute x here, but that's not true because it's not multiplication, it's a function. So take note of that. So letter B, if you want to subtract, then I just put minus here, or just write here f minus g. G's of x is f of x minus g's of x. Then if you want to multiply, it's all the same, f times g of x is equal to f of x times g's of x. Then for the last part, for the division, f divided by g of x is the same as f of x all over g of x. So these are the basic arithmetic combinations of functions. So that's the first part. Then let's take an example. If f of x is equal to x squared plus x minus 2 and g of x is equal to x plus 2, determine f of f plus g of x, f minus g's of x, all of them, f times g's of x, then and f over g of x. So solution. So for the first problem, f of g. So what is f plus g of x? So what we do, we just add them. So this is just f of x plus g's of x. And our f of x is x squared plus x minus 2. So that's given. Then plus g of x is x plus 2. So x plus 2. Then simplify. So f plus g now will be equal to x squared, then x plus x. So plus 2x, then minus 2 plus 2 is 0. So f of plus g of x is equal to x squared plus 2x. Next, for the minus, so f minus g of x is equal to, so this is also f of x minus g of x. So what is f of x? X squared plus x minus 2. Then we subtract. Remember to put quantity here. Most students are having a mistake when they subtract functions. They don't put quantity. They forgot to include quantity, or the minus sign is not distributed to the polynomial or any binomial functions, and that will be a mistake. So here, this will be x squared plus x minus 2. So if you remove that one, remove the negative sign. And if you remove the quantity, then change all sign that is inside that quantity if it's preceded with a negative. So this will be negative x, then minus 2. So distribute the negative. Then simplify further. So we have f minus g of x now will be equal to x squared, x minus x squared, then x minus x, this will be 0. We cancel out. Negative 2 minus 2 is negative 4. So this will be f of g, f minus g of x. Next, for the multiplication, f times g. So f times g of x, this will be f of x times g of x. So our f of x again is x squared plus x minus 2. So put quantity. Remember to put quantity here. X minus 2. You need to include all the parts of that function. You multiply it with g of x, x plus 2. Then how do you multiply? You can multiply just like that, and so on. Algebra. So this will be x squared times x, so x cubed. X squared times 2 plus 2x squared. X times x is x squared. x times 2 is 2x. Then minus 2 times x is negative 2x. Negative 2 times 2 is negative 4. Then simplify. F times g of x now will be equal to, we only have one term for x cubed. So this is x cubed plus 2x squared plus x squared. That's 3x squared. 3x squared. 2 plus 1. Then 2x minus 2x, this will be equal to 0. Then minus 4. So minus 4. So this will be f times g of x. And for the last part f divided by g of x, this will be equal to f of x divided by g of x. And f of x is x squared plus x minus 2. You divide it with x plus 2. How do we divide this one? We can do synthetic division, or we can do long division. So long division, remember your long division, x squared plus x minus 2. So if you divide this one with x plus 2, and I will multiply this one with x, because x squared divided by x is x. X times x is x squared. X times 2 is 2x plus 2x. Then you subtract this one. So this will be 0. X minus 2x. This will be negative x. Then bring down negative 2. Then what will I multiply with x plus 2 so that it will become negative x minus 2. So I just multiply it with negative 1. So this will be negative x minus 2. Then if I subtract this one, then I will have the 0. So x minus x, 0. 2 minus 2, 0. So therefore, the quotient of f and g is equal to x minus 1. You can also do synthetic division if you remember the synthetic division from your algebra, or you can always do long division. It's fine. This long division. Then I want to include some problems here. What if I want to solve? I want to include f divided by g of 2. So what is f of g divided by 2? So there are two ways in solving f divided by g's of 2. Two ways. The first way is we substitute directly this one, f of 2 divided by g's of 2. So let's try that one. So f of 2, what will be f of 2? So we already evaluated. We know how to evaluate function. What is f of x? F of x is x squared plus x minus 2. So here, so we just change all x with 2. So this will be 2 squared plus 2 minus 2. So that is f of 2. Then for g's of 2, that will be 2 plus 2. So 2 squared is 4. 2 minus 2 is 0. 2 plus 2 is 4. So this will be 4 over 4. So therefore, f of g of 2 will be equal to 1. 4 divided by 4. Another way to solve this one is to use what we have already solved here. This one, we already solved f of g of x. So we just change directly the value of x. So let's do that. F of g's of 2. So x minus 1. So we just change x with 2. So this will be 2 minus 1. And 2 minus 1 is equal to 1. So this means either way, if you substitute first before you combine, or you combine first before you evaluate, it's okay. It's the same. It's the same answer. You will arrive with the same solution. So this is combination, arithmetic combination of functions. There is another one, another type of combination, the more difficult type. We call it the composition of functions. Compositions of functions. So this is more difficult compared to the first one, the arithmetic. So what's the definition of this one? So there's a symbol, there's a notation. We used letter O. It's not letter, it's a circle, a small circle. This one. So we read this one as f composed of g of x. So this is equal to f composed of g's of x. So that's composition. We compose functions. So this is the basic definition of a composition functions. So let's take an example. So if f of x is equal to 1 plus the square root of x minus 2, and we also have g's of x is equal to x minus 3, and we want to determine f composed of g's of x, also g composed of f of x, and we can also do three compositions: f composed of g composed of h of x. So let's try to have another function here, h, and let's h of x be equal to x squared. So we want to determine this following. So solution. So for the first part, f composed of g. What is f composed of g? F composed of g's of x. This is the same as f of g's of x. And to do this one, so the technique is you just again change the value of you start with the smaller in the one that is inside here. So you do that first, you change that one. So f of g of x. I know g of x is x minus 3. So this will be f of x minus 3. Then we can already solve for f of x minus 3. We have an example like this one before the top. So f of x minus 3 will be equal to, so this is our f of x, 1 plus the square root of x minus 2. But change x with whatever inside the bracket, and that's x minus 3. So x minus 3. This is x originally here because this is f of x. Then you subtract it with 2. Then simplify it. Then, we can now solve for f of g of x. So this will be equal to 1 plus the square root of x minus 5. So this will be the composition f composed of g of x. For the second one, it's the inverse. G composed of f of x. So this will be g of f of x. So now we will first evaluate g of x inside that f of g. Evaluate f of x inside that g of x. So what is f of x? That's 1 minus the square root of x minus 2. And our g is x minus 3. So we just change x with f of x. So this will be, what is f of x? It's 1 plus x square root of x minus 2. So 1 plus the square root of x minus 2. So this is our f of x. Then we still need to subtract it by 3 because that is g's of x. So this is minus 3. And this is equivalent to g of 1 plus x minus 2. It's good practice that you always do this first before you evaluate them, so that it's easier for us to determine what should you put inside that volume. Then simplify. So we can now simplify. So this will be 1 minus 3 is negative 2. So x minus 2 minus 2. So this will be g's of x, f of x. Okay. Then the last part, we compose three functions, f of g of h of x. So f composed of h composed of no, it's g composed of g composed of h of x, and this is equal to f of g of h of x. So this is composition. So we change h first. So this will be f of g of what is h of x. H of x is x squared. So this will be g's of x squared. Then next is, what is g of x squared? Our g is equal to x minus 3. So I just need to change x here with x squared, because I want to solve for g of x squared. So don't forget, you can disregard first f, just solve for g of x squared. And that will be f of, so what is g of x squared? X minus 3, you just change x with x squared. So this will be x squared minus 3. And the last part is, what is f of x squared minus 3? So you can now just solve this one, because we know that f of x is 1 plus the square root of x minus 2. So this will be 1, then plus the square root of x minus 2. But instead of x, I put whatever inside this quantity, because I'm solving for f of x squared minus 3. So I put it here, x squared minus 3. This is originally x, but because I'm solving this one, so it should be f of x squared minus 3, then minus 2, then simplify. So we can now solve for the composition f composed of g composed of h of x. So this will be 1 plus the square root of x squared. Negative 3 minus 2 is negative 5. So this is f of g of h of x, or f composed of g composed of h of x. So that is composition of functions. So this is more complicated, because you evaluate functions inside the functions, but you just need to do it step by step. You start with the last one, the what is inside the bracket, then you go outward. Okay? Then let's go now to our next topic. This special type of functions. This will be our last topic. So the first one is the functions that we call one-valued and many-valued functions. So, well, we defined function before. A function is a relationship between two variables, an independent variable and dependent variable. So you put an input, at least one input, but your output or result is always one. You only have one result. And if that is the case, if you have, so for a one valued function, one valued, so this means you have one input, so this means one input and one output, one result, one domain input, one out of the domain, then one out of the range. So example is a polynomial f of x equals x cubed plus 1. If you input a value here, let's say 1, then you will have a single value x1 squared, 1 cubed plus 1. So 1 plus 1 is 2. So it's just 2, a single value. So that function can be considered as one valued function. How about a many valued function? A many valued function is a function that has multiple input but still with one output. Is it possible to have a multiple input with just one result? So multiple input, 2 or more inputs, and one output. Is it possible to have more than one multiple inputs? Yes. An example of that is f of x is equal to sine of x. Why is it a multiple output, sir? If I input 20 degrees here, sine of 20, is it more than 1? If you look at the graph of a sine, so a sine wave, so from your analog, so this is the graph of a sine wave. So if we take a single value here, so remember this one, this is our y, so this is our output. So let's say this is a constant c. So all throughout, if we draw this one, the function reaches the value c at multiple times. When and where? Here, 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 and here. And these are all inputs, x2, x1, x3, and x4. So, but they all have the same value c. If I input x1, the result is c. If I input x2, the result is still c. If I input x3, the result is also c. So this is a very good example of a many valued functions. How about a multiple output, sir? Is there a function that is called a multiple output? We call that one. There's what we call the multiple valued function. A multiple valued function is not considered a function. This is not a function. Not a function. But this is what we call the expression that has multiple output. So if you have multiple output, that is called the multiple valued function. And the normal function, they are single valued functions. These are the actual functions. So these are the actual functions. Actual functions. Although multiple valued are not function, they still name it as multiple valued function because it has multiple output. Okay? Then we also have odd and even functions. Odd and even functions. So what are odd and even functions? So an odd function, odd, when f of negative x is equal to negative of f of x. So example, again the sign f of x f of x equals sine x. So if I solve for f of negative x, this is sine of a negative x. So what is the sine of a negative x? So if you look at the unit circle, if you remember the unit circle here, so if I have here a value of x, then here is negative x. Then they have the same theta, but the other one is negative. Then here, this point here is x and y. This is cosine of x and sine of x. Here at the bottom, this is sine of negative x and or cosine of negative x and sine of negative x. So if we try to solve, if you look at the value for the x and the sine, so this length here, from here to here, is the same length as this one. It's symmetrical. This one is the same as this one. So what does this mean? This means it's equal but in the opposite way, because it's going downward, the other one is going upward, and they have both the same magnitude. So therefore, f of negative x here is just equal to negative of the positive. So here, this is sine of x. Here, this is negative sine of x. So if you take the sine of a negative x, it's just equal to negative sine x. So therefore, this is an odd function. And the cosine one, for the cosine, if you look at the cosine, we consider that one an even function. Why? Because it's always going to the right. This will be the value for the cosine. Here, this is cosine x. And it's even if it's negative, it's still going to the right. So what does this mean? This means it's still positive. So if you take f of negative x should be equal to the positive one. So if the example of an even is the cosine x, so f of negative x is equal to cosine of negative x. So if we go back to the unit circle, it's still in the right, so meaning it's still the positive. So therefore, we can conclude that this is an even function. So that is odd and even function. And the last one is the last type, special type, we call it the piecewise function. A piecewise function is a function composed of multiple sub-functions. So it's composed of multiple sub-functions. So for example, f of x is equal to, there's a symbol, a bracket here, x squared, 2, and 3x. So then conditions, x is less than 1, x is equal to 1, and 1 less than x greater than 4. So this is an example of a piecewise function. It is composed of 3 sub-functions, x squared, 2, and 3x. So what does this mean? This means when x is less than 1, the value of function is x squared. When x is exactly equal to 1, the value of the function is 2. And when x is greater than 1 and less than 4, the value of the function is 4. Is 3x. So if we try to draw the graph of that one, this will be the graph of that sub-function. So here, x squared when it's less than 1. So from this point toward that direction, then it's x squared, or it's a parabola. Then when x is equal to 1, this one is 1, then the value is 2. So this is exactly a point. Then after that, when it's greater than 1, then it became a straight line with a slope of 3, or y equals 3x. So this is y equals 3x, this is y equals x squared, and this one is y equals 2. So it's a composition of different sub-functions. So that is a piecewise function. We call it a piecewise function. So we're done now with chapter 1. So you can now have your long exam and your quiz after this one. So see you at the next chapter.